Hello, in this lecture we will find out the area of the green triangle. In the drawing we have square ABCD, and we know that all the sides of square ABCD, they are equal to 4 units, and inside this square we have this circle, and the radius of this circle equals to 1 unit, and we also have the green triangle, and we want to find out the area of this green triangle. So first of all, I will present to you a new rule, rule number 1. According to rule number 1, a tangent to the circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 1 again. Rule number 1 states that a tangent to the circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have a circle, we have this circle, and tangent AB, this tangent AB is perpendicular to this circle at this point. This is actually the point of tangency. We will define the point of tangency of tangent AB with this circle as point M, and the center of this circle will be defined as point O. From point O we will draw perpendicular to M, so OM is the radius. So the radius R, it is actually this radius. It is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So rule number 1 states that a tangent to the circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. So whenever we have a radius, like in this drawing, the radius OM, it is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency of tangent AB with this circle. So whenever the radius is drawn to the point of tangency, then according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so actually we can implement rule number 1 in our drawing. Here we define the center of this circle as point O, and this is the radius of the circle, and the radius R of this circle equal to 1 unit according to what is given us in the question. We will define the touching point or the point of tangency of tangent DA with this circle as point M. So actually the radius OM is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency of tangent AD with this circle. Therefore, according to rule number 1, the tangent AD, this tangent AD, will be perpendicular to this radius OM or MO. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? And actually we also know that all 4 angles inside, all the 4 angles inside the square are right angles. Therefore, this angle, this one out of 4 angles of square ABCD, will be a right angle, that is to say it equals to 90 degrees. So this is a right angle, and here we will define the point of tangency of tangent AB with this circle as point N. Again, point N is the point of tangency of tangent AB with this circle, and from point O we will draw radius to point N, or N is the radius of this circle because of the fact that line segment ON starts from point O, that is the center of this circle, and ends at point N, that is the point on the circle itself. Therefore, ON is defined as the radius, therefore it equals to 1 unit. And again we have this radius, the radius ON or NO, it is drawn to the point of tangency, that is to say radius ON, it is drawn to the point of tangency, that is to say it is drawn to point N, that is the point of tangency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees according to rule number 1. And we will also define the point of tangency of tangent CE with this circle as point K. Again, point K is the point of tangency of tangent CE, that is actually the hypotenuse of this triangle, right triangle, with this circle. And from point O, we will join points O and K together by a straight line. Actually, OK, it is the radius of this circle. okay, is the radius, it is the radius of this circle, that is to say it equals to 1 unit. OK is the radius of this circle because of the fact that line segment OK starts from point O, that is the center of this circle, and ends at point K, that is a point on the circle itself. Therefore OK is the radius of this circle. And again we have the radius OK or KO, it is drawn to the point of tangency, that is to say it is drawn to point K, that is the point of tangency of tangent CE with this circle. Therefore the tangent CE will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Okay? And we also have rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. The sum of the angles in any quadrilateral is equal to 360 degrees. So I'll read rule number 2 again. According to rule number 2, the sum of the angles, the sum of the angles in any quadrilateral is equal to 360 degrees. And we will focus on quadrilateral OMAN, on this quadrilateral. So quadrilateral OMAN, the sum of the angles in quadrilateral OMAN, this quadrilateral, is equal to 360 degrees according to rule number 2. Which angles we have here? We have 1, 2, 3 right angles. 1, 2, 3. And the sum of 3 right angles, it is actually 90 times 3, it is 270 degrees, plus the size of the fourth angle, this angle that we will define as angle X. The sum of those 4 angles must be equal to 360 degrees according to rule number 2. I will repeat again. In quadrilateral OMAN, the sum of the angles must be equal to 360 degrees according to rule number 2. So which angles we have with quadrilateral OMAN? We have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is angle X, must be equal to 360 degrees according to rule number 2. Here we will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So we found out that angle X is a right angle. So we change angle X by a right angle. So you can see in the drawing that all four right angles, all angles of quadrilateral MOAN are right angles, and we have also rule number 3. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. If not a square, it must be a rectangle. I will read rule number 3 again. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we found out that quadrilateral MOAN has 4 right angles, therefore it must be at least a rectangle, so we will relate to quadrilateral MOAN as a rectangle. According to rule number 3, it is a rectangle. I will repeat again. According to rule number 3, quadrilateral MOAN is a rectangle. And we also have rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. I will read rule number 4 again. According to rule number 4, the opposite sides of a rectangle are equal to each other. So we can implement rule number 4 in our rectangle MOAN. According to rule number 4, in rectangle MOAN, side MO equals to side AN. Side MO equals to side AN, according to rule number 4. I will repeat again. In rectangle MOAN, side MO equals to side AN, according to rule number 4. But it is given us in the question that MO equals to 1. So we know that MO equals to 1 unit. So from this equality, we will conclude that AN also equals to 1 unit. Okay, AN also equals to 1 unit. So we can write here that AN equals to 1 unit. Likewise, according to rule number 4, MA equals to ON. I'll repeat again. Side MA equals to side ON according to rule number 4. But we have already know that ON equals to 1 unit. So we can write here that ON equals to 1 unit. ON equals to 1 unit. So from this equality, we will conclude or we will derive that MA also equal to 1 unit. MA equals to 1 unit. MA side MA equals to 1 unit. So we can write here that MA equals to 1 unit. So actually we found out that all 4 sides of rectangle MOAN are equal to each other. They are all equal to 1 unit. And also all the angles inside rectangle MOAN are also equal to each other. They are right angles. And we have rule number 5. According to rule number 5, if a quadrilateral has 4 right angles and 4 equal sides, it must be a square. So I will read rule number 5 again. According to rule number 5, if a quadrilateral has 4 right angles and 4 equal sides, it must be a square. And we actually found out that quadrilateral MOAN has 4 right angles and 4 equal sides, therefore quadrilateral MOAN is a square. According to rule number 5, quadrilateral MOAN is a square. According to rule number 5, and we also have rule number 6. According to rule number 6, the diagonals of a square bisect the angles of the square into 45 degrees angles. I will read rule number 6 again. According to rule number 6, the diagonals of a square bisects the angles of the square into 45 degrees angles. So actually, according to rule number 6, the diagonal OA or AO, this diagonal, bisects angle DAB into 2 angles of 45 degrees. That is to say, this angle will be equal to 45 degrees and this angle will be also equal to 45 degrees, according to rule number 6. So we can write down that according to rule number 6, angle OAB equals to 45 degrees. Okay, we can write down that angle OAB equals to 45 degrees, according to rule number 6. Likewise, the big diagonal AC of square ABCD the diagonal AC of CA bisects angle A into angles of 45 degrees. That is to say, this angle equals to 45 degrees and this angle equals to 45 degrees. So actually angle CAB will be also equal to 45 degrees. Again, according to rule number 6, angle CAB will be also equal to 45 degrees. According to rule number 6. So actually, those two angles are both equal to 45 degrees, therefore they are equal to each other. So we can write down that angle OAB equals to angle CAB. Angle OAB is equal to angle CAB. And both angles are equal to 45 degrees. Okay, so you can see from the drawing that angle OAB, this angle equals to 45 degrees, and also angle CAB will be also equal to 45 degrees. From the fact that those two angles are equal to each other, we will conclude that the diagonal CA passes through point O. So I write it down. We will conclude from the fact that angle OAB equals to angle CAB, that the diagonal CA of square ABCD passes through point O. Okay? The diagonal CA passes through point O. Why? Because angle CAB equals to angle OAB. Otherwise, if diagonal CA doesn't pass through point O, then it is impossible that angle CAB will be equal to angle OAB. But because of the fact that those two angles are equal to each other, it must be that the diagonal CA passes through point O. Otherwise, those two angles, angle CAB will never be equal to angle OAB. Okay? Therefore, we will conclude that the diagonal CA of square ABCD passes through point O. Okay? So, in the next step, I will present to you a new rule, rule number 7. According to rule number 7, the length of the diagonals of a square is equal to square root of 2 multiplied by the square side multiplied by the length of the square sides. Okay, so I will repeat on rule number 7 again. According to rule number 7, the length of the diagonal of a square is equal to square root of 2 multiplied by the length of the square's sides. So what is the meaning of rule number 7? The meaning of rule number 7 is that if we have square ABCD, so we have square ABCD, this is square ABCD, and we know that the length of one side of square ABCD is equal to S units, so all the sides, the lengths of all the sides are S units. If the length of this square ABCD equals to S units, then the length of its diagonal BC the length of diagonal BC will be equal to square root of 2 times S units. I'll repeat again. If we know that the length of one side of square ABCD is equal to S units, then the length of diagonal BC of square ABCD will be equal to square root of 2 times S. Okay, and we actually can implement rule number 7 in our drawing. So the length of diagonal OA of square MOAN, according to rule number 7, will be equal, so we will relate to square MOAN in square MOAN, the length of diagonal OA, according to rule number 7, will be equal to the length of the side of square MOAN that is actually equal to 1 unit times square root of 2. Square root of 2 times 1 is square root of 2 units. So we actually found out that the length of diagonal OA of square MOAN equals to square of 2 units. Likewise, we will calculate the length of diagonal AC of square ABCD. I'll repeat again. We will relate to square ABCD and we will calculate the length of diagonal CA. The length of diagonal CA will be equal to the length of one side of square ABCD, that is actually equals to 4 units, times square root of 2. So we actually found out that the length of diagonal CA of square ABCD equals to 4 times square root of 2 units. Okay, CA equals to 4 times square root of 2 units. And what is the length of CO? CO, as you can see from the drawing, CO equals to CA minus OA. Again, CA minus OA equals to CO. Okay, so I write it down. CA minus OA equals to CO. That is to say, CO equals to CA. We already found out that CA equals to 4 times square root of 2 units minus OA equals to square root of 2 units. So 4 times square root of 2 units minus 1 times square root of 2 units equals to 3 times square root of 2 units. That is to say, CO equals to 3 times square root of 2 units. So we can write here that CO, this line segment, equals to 3 times square root of 2 units. Okay. In the next step, we will focus on the right triangle, triangle COK. This right triangle, triangle COK. In triangle COK, according to Pythagoras theorem, the right triangle, triangle COK, according to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, triangle COK, it is CO. It is the angle in front of the right angle. CO, it is the hypotenuse of the right triangle, triangle COK. Therefore, the square of the hypotenuse is CO squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to KO squared plus CK squared. So I will repeat again. In the right triangle, triangle COK, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, it equals to CO square plus KO square plus CK square. We have already found out that CO equals to 3 times square root of 2 units. Therefore, CO square will be equal to 3 times square root of 2 units square, and it equals to KO square. KO is the radius of this circle, that is to say it equals to 1 unit, so KO is 1, so KO is 1 square. 1 square is 1 plus CK square. CK square is the missing variable. So in total, in conclusion, we found out that CO square is 3 times square root of 2 square, and it equals to KO square, that is 1, plus CK square. The square of 3 times square root of 2, it is actually 9 times 2, and 9 times 2 equals to 1 plus CK square. Okay? Here 9 times 2 is 18, so I'll write it down. We get that 18 equals to 1 plus CK square. We will subtract from equation number 1, and we will get that 18 minus 1 is 17. 17 equals to CK square, according to equation number 1. So CK square equals to 17. We will take a root out of equation number 1, and we will get that CK equals to the square root of 17. CK equals, CK, according to equation number 1, CK equals to the square root of 17. Okay, CK equals to the square root of 17. So we can write here that CK, this 9 segment, equals to the square root of 17. Okay? In the next step, I will present to you a new rule, the last rule, rule number 8. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So I'll read rule number 8 again. Rule number 8 states that the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if you have a circle, this circle and we also have this external point, point P. Point P is an external point because of the fact that point P, so it is external point in relation to this circle. Why? Because point P is not located inside this circle, nor on this circle, therefore point P is defined as an external point. So if from the external point, point P, we will draw two tangents to this circle, the first tangent will be this tangent. We will define the point of tangency of the first tangent with this circle as point A, and we will also draw a second tangent from the common external point, point P, to the circle. This will be the second tangent, and we will define the point of tangency of the second tangent with this circle as point B. So the length of the first tangent is PA, and the length of the second tangent, it is actually PB, and according to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So whenever you draw from the common external point, like this common external point, point P, two tangents to a circle, the first tangent is PA, the second tangent is PB, then the length of those two tangents will be equal to each other. That is to say, PA will be equal to PB according to rule number 8. Okay, I'll repeat again. Whenever you draw from a common external point two tangents to a circle, then the length of those two tangents will be equal to each other. In this case, PA equals to PB. And you can actually implement rule number 8 in our drawing, because in our drawing we have the external point, point E. This point E is an external point in relation to this circle, and from point E we have two tangents to this circle. The first tangent is tangent EN, and the second tangent is tangent EK. And according to rule number 8, whenever you draw two tangents to a circle from a common external point to that circle, then the length of those two tangents will be equal to each other. That is to say, En equals to Ek according to rule number 8. And if we define En as K, that is to say En equals to X, En equals to X according to our definition, then because of the fact that En equals to Ek, then Ek will be also equal to X. Okay? You can conclude from this equality that Ek, if X equals to En equals to Ek, then Ek will be also equal to X. Ek will be also equal to X. So this angle is a right angle because it is one out of four angles of square ABCD, therefore it is a right angle, that is to say it equals to 90 degrees, and this, if this angle ABC equals to 90 degrees, then the green triangle is a right triangle. So we will focus, but before that we will find out the length of side EB of the green triangle. The length of side EB equals to EB equals to AB minus AN minus EN. It equals to AB minus AN minus NE. I will repeat again. You can see from the drawing, you can see that EB, line segment EB equals to AB, that is the length of one side of triangle square ABCD, minus AN minus NE. Okay, AB minus AN minus EN equals exactly to EB. Okay, so EB equals to AB. All the sides of square ABCD are equal to 4 units, so AB also equals to 4 units. AN, we have already found out that AN equals to 1 unit. AN equals to 1 unit. And NE equals to X according to our definition. So in conclusion, we found out that EB equals to 4 minus 1 minus X. 4 minus 1 is 3. So in conclusion, EB equals to 3 minus X. EB equals to 3 minus X. So we can write here that EB, the one side of the green right triangle, equals to 3 minus X. Okay? EB equals to 3 minus X, and the BC is one side of square ABCD, therefore it equals to 4 units. So we will focus on the right green triangle, triangle CEB. In the right green triangle, triangle CEB, according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right green triangle, triangle CEB, it is CE. Therefore the square of the hypotenuse, it is actually CE square. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB square plus BC square. So I will repeat again. In the right green triangle, triangle CBE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CE square equals to EB square plus BC square. What is the value of CE? You can see from the drawing that CE equals to square root of 17 plus x. Therefore, CE square will be equal to square root of 17 plus x square. Okay. CE square equals to square root of 17 plus x square. And it equals to EB square. You can see, as you can see from the drawing, EB equals to 3 minus x. So EB square will be equal to 3 minus x square plus BC square. BC equals to 4 units, so BC square is 4 square. 4 square is 16. So in conclusion, we found out that the square root of 17 plus x square equals to 3 minus x square plus 16. We will open the brackets in both sides of equation number 2, and we will get that square root of 17 plus x square is 17 plus x square plus 2 times square root of 17 x, and it equals 3 minus x square is 9 plus x square minus 6x plus 16. So here we have x square on both sides of equation number 2, so x square will get cancelled. And we also know that 16 plus 9 is 25, so I'll write it down. In conclusion, we will get that 17 plus 2 times square root of 17 x equals to 25 minus 6x. Here we will subtract 17 from this equation, equation number 2, and we will get that 17 minus 17 is 0. So here what is left, it is actually 2 times square root of 17 x. It equals to 25 minus 17 is 8 minus 6x. We will divide this equation, equation number 2, by 2, and we will get that 2 over 2 is 1, so here what is left is only square root of 17 x, and it equals to 8 over 2 is 4, minus 6 over 2 is minus 3x. So here we will we will add to this equation, equation number 2, 3x, and we will get that square root of 17 x plus 3x equals to 4. So I actually got that after we add 3x from this equation, we got that square root of 17 x plus 3x equals to 4. So here we will take a common factor x from these expressions, and we will get that we will take out the common factor x from these expressions, and we will get that. So x is a common factor. So what is left from square root of 17x after we took a common factor x? After we took from it a common factor x, what is left is square root of 17. And what is left from 3x after we took x as a common factor from it? What is left? It is actually 3, and it equals to 4. So here we will divide this equation number 2, by square root of 17 plus 3, and we will get that x equals to 4 over square root of 17 plus 3. Okay? So here we will multiply this side of equation number 2 by square root of 17 minus 3, and then we will divide it by square root of 17 minus 3 in order to get rid from the root in the denominator. So we will multiply this side of equation number 2 by square root of 17 minus 3, and then we will divide it by square root of 17 minus 3. So we got this expression. We will solve. We found out the value in the denominator by using the algebraic identity that states that a minus b times a plus b equals to a square minus b square. I will repeat again. We'll use this trigonometric, this algebraic identity that a minus b times a plus b equals to a square minus b square in order to find out the value of the expression in the denominator of this equation number 2, and we will get that x equals, according to equation number 2, x equals to 4 times square root of 17 minus 3 divided by, here a equals to square root of 17 and b equals to 3. And a plus b, a minus b equals to a square minus b square. So it is actually equals to a square. A square is the square root of 17 is 17 minus b square. B is 3, so b square is 3 squares. 3 square is 9. So in conclusion, we arrive to this expression. So here, according to equation number 2, here 17 minus 9 is 8, so I write it down. So x equals to 4 times square root of 17 minus 3 over 8, because 17 minus 9 is 8. So here we will divide this side of equation number 2 by 4. 4 over 4 is 1 and 8 over 4 is 2, so I will write it down. In conclusion, we will get that x equals 4 over 4 is 1, square root of 17 minus 3, 8 over 4 is 2. So we found out that x equals to square root of 17 minus 3 over 2. And what is the area of the green right triangle, triangle CBE? The area, the formula for the area of any triangle, it is actually equals to the base of the triangle times the height to the base over 2. This is the formula for the area of any triangle. Okay, the base times the height to the base over 2 is the formula for the area of any triangle. The area of our triangle, triangle CEB, actually this is the sign of the area. It means the area of triangle CEB equals to the base of the triangle. Here the base of triangle ECB is EB. EB times the height to the base. The height must create 90 degrees with the base, and indeed CB or BC creates 90 degrees with the base, so the height is BC over 2. Okay, we found out that according to equation number 3, the area of the green right triangle, triangle CEB equals to EB times BC over 2. Okay, so according to equation number 3, the area of the green right triangle, triangle CEB equals to EB. As you can see, EB equals to 3 minus x. Okay, here EB equals to 3 minus x, and BC equals to 4 units. Over 2. So we actually found out that according to equation number 3, the area of the green right triangle, triangle ECB equals to 3 minus x times 4 over 2. 4 over 2 is 2, so I will write it down, and we will get that the area of the green right triangle, triangle ECB or CEB is equal to 2 times 3 minus x. Okay? We have already found out that x, according to equation number 2, equals to square root of 17 minus 3 over 2. Okay, so we will place the value of x inside x in equation number 3. So we will place the value of x from equation number 2 in x from equation number 3. Okay? and we will get that the area of the green right triangle CEB is equal to 2 times 3 minus x, and x equals, according to equation number 2, to square root of 17 minus 3 over 2. Okay? So the area of the green right triangle CEB equals to 2 times 3 minus square root of 17 minus 3 over 2. So here we will multiply 3 by 2 and then we will divide it by 2 in order to have a common factor with this expression. And we will get that the area of the green right triangle CEB, according to equation number 3, is equal to 6 minus square root of 17 minus 3 over 2. So here 2 over 2 is 1, so 2 will get cancelled. And what is left after we cancel 2 in equation number 3? What is left from equation number 3 is that the area of the green right triangle CEB, according to equation number 3, is equal to 6 minus square root of 17 minus 3. So we found out that the area of the green right triangle CEB equals to 6 minus square root of 17 minus 3. Here we will open the brackets of this equation number 2, and we will get that the area of the green right triangle CEB, according to equation number 3, is equal to 6 minus square root of 17. Minus times minus is plus, so it's minus 3 is plus 3. Okay? So the area of triangle CEB is equal to 6 plus 3 minus square root of 17. I'll write it down. The area of the right green triangle CEB equals to 9 minus square root of 17 square units, or in terms of numbers it equals to 4.88 square units. I'll repeat again. We actually found out that the area of the green right triangle CEB equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle CEB it equals to 4.88 square units. I will repeat again. The area of this green right triangle CEB equals to either to 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle it equals to 4.88 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the area of this green triangle CEB, and we have here square ABCD. One side of square ABCD is equal to 4 units. Inside this square, we have this circle, the radius of this circle equals to 1 unit, and we want to find out the area of this green triangle. So first of all, I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this circle and you have tangent AB is tangent to this circle at point M. Point M is the point of tangency, and you have this radius, the radius OM, it is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency of tangent AB with this circle. So whenever the radius is drawn to the point of tangency, then the tangent AB will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equal to 190 degrees. We implemented rule number 1 in our drawing. In our drawing we have this radius that is drawn to the point of tangency, that is to say it is drawn to point M. Therefore the tangent AD will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Here, this angle DAB, it is 1 out of 4 angles of square ABCD, and we know that all the angles inside the square are right angles, therefore this angle is a right angle, that is to say it equals to 90 degrees. And here we have this radius that is drawn to the point of tangency. Therefore, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. We also have this radius that is drawn to the point of tangency. Therefore, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then, I presented to you rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So if we focus on quadrilateral MOAN, the sum of its angles must be equal to 360 degrees. It has 3 right angles, and the sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is x. It must be equal to 360 degrees according to rule number 2, that is to say 270 degrees plus angle x equals to 360 degrees according to rule number 2. We subtracted 270 degrees from this quality and we got that angle x equals to 90 degrees. So this angle is a right angle, therefore all 4 angles inside quadrilateral MOAN are right angles. And we have rule number 3 that says that any quadrilateral that has 4 right angles, it must be at least a rectangle if not a square. So because of the fact that quadrilateral MOAN has 4 right angles, we will relate to it as a rectangle. Okay, and we have rule number 4 that states that the opposite sides of a rectangle are equal to each other. It means that MA equals to ON, MA equals to ON, but we know that MO equals to AN, but MO equals to 1. So from this equality we will conclude that AN also equals to 1 unit, and we also know that MA equals to NO according to rule number 4, but we also know that NO equals to 1 unit. So from this equality we will derive that MA also equals to 1. So we found out that all sides of quadrilateral rectangle MOAN are equal to each other, and it also has 4 right angles. And we have rule number 5 that if a quadrilateral has 4 right angles, it must be a square. So because of the fact that quadrilateral MOAN has 4 right angles and 4 equal sides, according to rule number 5, it must be a square. So because of the fact that quadrilateral MOAN has 4 right angles and 4 equal sides, it must be a square according to rule number 5. And we also have rule number 6 that says that the diagonals of a square bisects the angles of the square into 45 degrees angles. So the diagonal OA of square MOAN bisects this angle into two angles of 45 degrees, that is to say this angle equals to 45 degrees and this angle also equal to 45 degrees. And actually angle OAB equals to 45 degrees according to rule number 6. Likewise in square ABCD, the diagonal CO bisects this angle to two angles of 45 degrees. That is to say angle CAB equals to 45 degrees according to rule number 6. So angle OAB equals to angle CAB because both of them are equal to 45 degrees, and because of the fact that those two angles are equal to each other, we will derive that angle C, that diagonal CA must pass through point O. Okay? The diagonal CA of square ABCD passes from point O, otherwise angle CAB will not be equal to angle OAB. But because of the fact that they are equal to each other, therefore diagonal CA passes from point O. And we also have rule number 7 that says that the length of the diagonals of a square is equal to square root of 2 multiplied by the length of the squared sides. So what rule number 7 means that if the length of one side of square ABCD equals to S units, then the length of his diagonal BC equals to S times square root of 2 units. Okay? And we actually implemented rule number 7 in our drawing because OA will be equal to 1 times square root of 2 units, because 1 is the length of one side of square MOAN. Therefore, according to rule number 7, OA will be equal to square root of 2 units, and in square ABCD, the length of diagonal CA will be equal to 4 times 2, because 4 is the length of the one side of square ABCD, and we must multiply it by square root of 2 in order to get the length of diagonal CA. So according to rule number 7, CA equals to 4 times square root of 2 units, and CO equals to CA minus AO, that is to say CO equals to square root of 2, 4 times square root of 2 minus square root of 2, that is to say CO equals to 3 times square root of 2 units. And then we focused on the right triangle COK. According to the Pythagoras theorem, CO square equals to OK square plus CK square in this right triangle. But we know that CO equals to 3 times square root of 2 units, so CO square will be equal to square root of 3 times square root of 2 square. OK equals to 1, so OK square is 1 square, 1 square is 1, plus CK square. We solved this equation and we found out that CK equals to square root of 17 units. CK equals to square root of 17 units. And then I presented to you rule number 8. According to rule number 8, the length of two tangents from a common external point to a circle are equal. What is the meaning of rule number 8? The meaning of rule number 8 is that if we have a common external point, point P, and from point P we draw two tangents to this circle, then the length of those two tangents will be equal to each other, that is to say PA equals to PB. And we can implement rule number 8 in our drawing, because in our drawing we have the external point A, and from the external point E, from the external point E we have two tangents to this circle, therefore EK will be equal to EN according to rule number 8. EK equals to EN according to rule number 8. We defined EN as X, therefore EK will be also equal to X. And what is the size of EB? can see from the drawing that EB equals to AB minus AN minus NE. That is to say, EB equals to AB, that is 4, minus AN, that is 1, minus NE, that is X. So 4 minus 1 minus X is 3 minus X. So we found out that EB equals to 3 minus X. And then we actually focused on the green right triangle, triangle CBE. It is a right angle because this angle is 1 out of 4 angles of square ABCD, and all 4 angles of square ABCD are right angles. So we implemented the Pythagoras theorem in the right triangle, triangle CEB, and so according to the Pythagoras theorem, CE squared equals to EB squared plus BC squared. And after we solved this equation, we found out that X equals to actually square root of 17 minus 3 over 2 units, and the area of the right green triangle CEB equals to the base times the height over 2. The base is EB, the height is BC. We divided it by 2, and we got that the area of the green right triangle, triangle CEB, it is actually equals to either to 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle, triangle CEB, it equals to 4.88 square units. Okay? Thank you very much.